When looking at electron configuration, we need to define the different parts of the quantum mechanical model, which is the electron cloud model. So the first thing that we need to talk about is energy level. Energy level is defined as the distance of the electrons from the nucleus. So I've added this graphic here to show you how when we have the first energy level, the electrons are a little close to the nucleus. Second energy level, the electrons are moving a little further from the nucleus. And the third energy level, the electrons are even further from the nucleus. So again, energy level is the distance of the electrons from the nucleus. All right, sublevel is a little interesting. Sublevel represents an area of probability that represents the electron's location. All right, why do we call them areas of probability? That's because, according to the quantum mechanical model, the electron, we're not actually able to pinpoint exactly its location. We're only allowed to know essentially a cloud or an area of probability the electron is likely to be on. These different clouds or areas of probability have names, and those names are letters. So the S area of probability looks like a sphere, the P area of probability looks like a figure 8, and the D area of probability looks like a 4-leaf clover. So I've added those graphics here. So remember, these represent different areas of probability. The higher the energy, the area of probability, the more complex its shape is. So that's why it's called the electron cloud models, because we're able to know clouds or areas of probability of the electron's location. All right, when we start to describe where the electron is in the atom, we use electron configuration. The large number up front represents the energy level, or the distance those electrons are from the nucleus. Then we have the letter following the energy level. That area represents the sublevel, or the area of probability. And those have names that are letters. So the first one that we have, at least in this example, is an S, or a spherical area of probability. The superscript tells you the quantity of electrons that are in that area of probability. So let's go ahead and do some examples. The first example we have is lithium. So what we're going to do is we're going to look at lithium on the periodic table. All right, lithium is in the second row. Remember, the first thing that we do is we look at the row number to tell us the area of probability. We also look at the block or area of the periodic table that the electron is in. So remember that this area, at least on this periodic table, is blue, represents the S area of probability, and on this periodic table, the green area represents the P area of probability. And then of course we have the D and the F area of probability also, but we spend the majority of our time looking at S and P. So that was just a little review. Let's take a look at lithium. Lithium is here. We need to include all of lithium's electrons. Recall that lithium, we look at its atomic number, which is 3, and we have to represent all of lithium's electrons. So we have to work from the inner electrons to the outer electrons. So the inner electrons are going to be 1s, and we count over 2 squares, so 1s2. And then we have the second row, which is the second energy level, 2. We're in the S area of probability, and we count over 1 squared, 2s1. Now, those superscripts should add up to the number of electrons that lithium has, 3. So here's how you do superscripts in this program, Cami. After you click, this toolbar is going to come up here at the top. And the superscript tool is up here. So what I'm going to do is I'm going to click on that superscript button whenever I need to write a superscript. So I'm just going to start typing. I have 1s. Now I'm going to hit the superscript button, 2. Now to get out of superscript mode, you click on it again. And then we said 2s, and then I'm going to click on the superscript button again, 1. All right, so this is the electron configuration for lithium. And notice how all of these electrons, the 2 and the 1, they all add up to the total quantity of electrons that lithium had, which was 3. All right, let's move a little bit faster through our next example. Our next example is nitrogen. All right, so let's find nitrogen. Here it is. And so for nitrogen, we need 7 total electrons. So we start with the first energy level, 1s2. We go to the second energy level, 2s2. 2 squares there. Now we have to continue all the way across that second row before we can get to nitrogen. So as we go all the way across that second row, we're going to get 2. This is the P, and we count over 1, 2, 3 spaces, so 2p3. All right, so let's go back to our answer. Remember, in Cami, you use the text box. So we have 1s2, 2s2, and 2p3. All right, let's move on to another one. Let's do sodium. Sodium's all the way down here in the third energy level. So we're going to have to go all the way through the first and second rows before we can get to sodium. So we're going to go 1s2, 2s2. We have to finish the second row, so 2p, and then we count over 1, 2, 3, 4, 5, 6 squares, so 2p6. Then to get to sodium, we have 3s1. So let's go ahead and write that in our answer table. So 1s2, 2s2, 2p6, and then 3s1. All right, let's do another one. This time I want to do silicon. Silicon is in our example here, so that's the one I'm going to work on next. So let's go ahead and try silicon on the periodic table. All right, silicon is all the way down here. It's in the third row. So that means I'm going to have to go all the way through the first, second, and then the third row until I get to silicon to take into account all 14 of its electrons. So we're going to go 1s2, 2s2, finish the second row, 2p6, then keep going, 3s2, and I need to go all the way across the row to get to silicon, so 3p1, 2, so 3p2. So that one's going to be a little bit longer to write. So we're going to have 1s, and then we need to hit our superscript button, 2, 2s. Oh, well, that didn't work. Let me try again. 1s. Oh, I hate this. All right, let's try again. Sorry. 1s2. I don't know why that's not working. Let's just draw another box. All right, start over. 1s2, 2s2, 2p6, 3s2, and then we finally said 3p, and we counted over 2 squares. All right, don't forget that hydrogen is a little bit weird. Because hydrogen, in this example, it only has one electron, its electron configuration is super short, 1s1. It only has one electron, so don't be fooled on that one. It literally is that simple, so don't try to make it more complex. It only has one electron. All right, let's do some of these where we have the abbreviated or noble gas configuration of elements. So this is where we're going to look for the noble gas that ends the row for the element we're looking at. So the first example is aluminum. All right, so aluminum is here, and oh, that's eraser, I don't want that. All right, so for aluminum, we need to figure out what noble gas ends the row before aluminum. So aluminum is here in the third row. So what noble gas ends the second row? So let's go up to the second row. The noble gas that ends the second row is here. It's neon. So just for review, don't forget, oh, I really wanted a highlighter. That's fine. So don't forget that this column right here is our noble gases. All right, so neon is the noble gas that ends the row before aluminum. So we're going to go from neon, and then we're going to go through the row until we get to aluminum. 3s2, 3p1. So let's go ahead and type that in. So remember to use your square bracket. So we got neon, and then after neon we had 3s2, and then we had 3p1. All right, let's try another one. The next one we could do, let's mix it up a little bit. Let's do calcium. All right, so for calcium we need to find that on the periodic table. Here it is. It's all the way in the fourth row. So in order for calcium's electron configuration in the fourth row, we need to find the noble gas that ended the third row. So we go to the third row, and the noble gas that ended the third row is argon. So we're going to use argon, then everything that comes after argon until I get to calcium. So argon, 4s1, 2. So argon, and then 4s2. So let's go ahead and type that as our answer. Don't forget to use your square bracket. So argon, then we had 4s, and we counted over 2 squares. All right, the next one that we can do as a group, let's go ahead and do, how about phosphorus? Okay, phosphorus, this example here, we're going to find on the periodic table. There it is. So phosphorus is in the third row. We need to find the noble gas that ended the row before phosphorus. So the noble gas that ended the row before phosphorus is neon. So we're going to take neon, and we're going to put that in square brackets, and we're going to go neon, and then to get to phosphorus, we're going to do 3s2, 3p3. All right, so let's go ahead and type that in. So for phosphorus, don't forget to use your square brackets. We've got neon. And then we said after neon, we had 3s2, and then we had 3p, and then we counted over 3 squares.